Okay, so let's take a look at 120. Okay, we'll just go to Mathematica here. So, oops, I didn't get that right. Okay, so 120.
Yep.
Factor integer tells me it's 2 cubed times 3 to the 1 times 5 to the 1. And it says here are all the divisors of 120, and they add up to 360. So let's see if we could have figured that out from the fact that we knew it was 2 cubed times 3 to the 1 times 5. So what would we do?
Well, for 2 cubed, we can figure out how many divisors there were for 2 cubed, which is 8 times, it's 8 plus 4 plus 2 plus 1.
It's 15.
Okay, so we gotta do 15.
Plus, times. Then 4.
4
Times 6.
times 6. And what is? How can we do 15 times 4 times 6 without needing Mathematica?
15 times 4 is 60.
60 times 6 is 360.
Yep.
There you go. Alright, now give me another one. Give me an integer.
Let's say 348.
Ooh, good one. Okay. So 348 factors into 2 squared times 3 times 29. Did you pick 348 because you have all the multiples of 29 memorized?
No.
No. Okay. The divisors of 348 are 1, 2, 3, 4, 6, 12, 29, 58, 87, 116, 174, 348.
Big numbers.
Yeah, and they add up to 840. So how could we have figured that out just from knowing it was 2 squared times 3 times 29?
2 squared, you have 4 times 2 times 1, which is, it's 7.
Please say it correctly.
You have, so for 2 squared,
Yeah.
you have 2 squared
Yeah?
times 2 times 1. Or 2 squared plus 2 plus 1.
Okay, which is it? Is it plus or times?
It's plus.
Why?
Because that's what we derived.
What did we derive?
For the powers of 2.
Yeah?
We derived it as plus.
What is it?
We derive it, so for primes
Yeah?
to primes to some number,
Uh-huh.
it's
What
that-
is it? What is it here?
the formula
For?
for these the primes to some number.
Yes, the formula for what, though?
The formula for calculating the sum of divisors of primes to some number.
The sum of the divisors.
Yes.
We're calculating the sum of the divisors here. So, do we multiply?
No, because we're trying to find the sum.
Okay, so we're finding the sum. We're finding the formula for the sum. It's complicated because we do multiply at the end. Right, but we multiply a bunch of sums together. Right, so it is confusing. So you got to remember what you're doing. So first, for 2 squared, what are we trying to do?
We're trying to find the sum of divisors of 2
We're
squared,
trying to find the sum of the divisors of 2 squared, which is what?
which was 7.
7. Okay, and how about the sum of the divisors of 3?
Well, just 4.
Okay, and what about the sum of the divisors of 29?
It's
30.
7 times 4 times 30. Is there a quick way to do that?
Well, it's 210 times 4,
Okay,
which is 840.
there we go. 840, just like we found. So the sum of divisors formula is not just some completely random number. So, sorry, the sum of the divisors, not the formula, the sum of the divisors of a number is not just a totally random number. It relates to the sum of the divisors of all the individual prime parts of the number.
Cool.
Yeah, and it's pretty neat. Let's do one more, just as an example.
Okay.
Can you pick a number?
How about 1048?
Okay, awesome. Ooh! This number just happened to be 2 cubed times 131 to the first power.
Cool.
Okay? So it has these factors. 1, 2, 4, 8, 131, 262, 524, 1048, and the sum is 1980. Okay? And how could we have figured that out right from the beginning? Can you explain it to me?
Well, we have a 2 cubed, which we learned was 15.
What is 15?
Well, it's 8 It's 8 plus 4 plus 1. What's 8 plus 4 plus 2 plus 1?
Okay, what is that? What does that represent?
It represents 2 cubed plus 2 squared plus 2 plus 1.
Yeah, those are the numbers. But what are those numbers representing?
Those are. It's how you calculate. It's how you calculate the. So you calculate what the sum of the divisors is.
Right, it's the sum of the divisors of 8. The sum of the divisors of 8 is 15. Now, for the super challenge problem, what is the sum of the divisors for 131?
It's 132.
How did you know that?
It's 131 plus 1.
There you go, because 131 is prime. So we have to do 15 times 132, which is 1,980.
It's not really a quick way to do that.
No, it's nice to have Mathematica to help
Yeah.
you with that. So it's actually pretty neat. Now, I haven't shown you why this formula is true. We've just sort of stumbled on this formula.
Yeah.
But I think I'm going to leave it at that because we've been talking for a while. But it shows you that what seems like a completely random thing when you're summing up the divisors actually comes from the primes.
Cool.
Yeah, it's pretty neat. All right, good job. Good job, guys.